Hello dear students, so we are going to start with another question, and the A part of the question is, will the current flow more easily through a thick wire or a thin wire of the same material when connected to the same source? When they are saying when connected to the same source, that means the value of the potential difference across them would be the same. So let us see the question once again. Will the current flow more easily through the thick wire or a thin wire of the same material when connected to the same source? Now, to be able to answer this, we have to use this formula. V is equal to IR. So from here, we get I is equal to V over R. Is that okay? Now, in both of them, the value of V is same. So, more current will be flowing in the case where the resistance will be smaller. Now, coming to the expression of the resistance. So, expression of the resistance we know is rho L over A. Now, other parameters remaining the same. We can easily see in case the area is more, the resistance will be less. And in case the resistance is less, we place a smaller value of resistance here in the denominator, will give us larger value of the current. So from here itself we can come to know the thick wire, which has got relatively larger value of the area, will have smaller value of resistance, and smaller the value of resistance, larger will be the value of current for the same value of the potential difference. So, in which wire will the current flow more easily? You can say in the thick wire the current will flow more easily. Further, you can express it more systematically if you want. You can write this as equation number 1 and write this as equation number 2. Now, using equation number 2 in equation 1, we can write what is I equal to. I can be written as V. In place of R, we can write rho L over A. Now this A will go in the numerator. So we write V A rho L. Now, as the value of V is same, material is same, so the value of resistivity is same, and length we are keeping the same. So the wire which has got larger value of area will have larger value of current. So easily you can make out the thick wire, through the thick wire the current will flow easily. So that with that we complete A part of the question, and we are coming to the B part of the question now. So you can see there on the screen which alloy is used to make heating element and what are its properties. So which alloy is used for making the heating elements? Do you know? It is the nichrome. Now, what is the property of the nichrome wire? Nichrome wire has got high resistivity. Now, do not think that it is a sort of an insulator. No. When we are saying high resistivity, we are comparing the resistivity compared to silver or copper. So, compared to silver and copper, it has got high value of resistivity. Otherwise, nichrome is also a conductor. Please remember that. And another property is that in spite of remaining at very high temperature, it does not get oxidized. That means it will be able to serve you for a long period. The material will not easily get spoiled. So, what are the property? So first property, it has got very high resistivity compared to the resistivity of very good conductors like silver or copper. And second property is it does not easily oxidize even at a very high temperature at which it operates. We know when the current is flowing through it, it becomes absolutely red hot. Now coming to the C part of the question. C part of the question is a 10 ohm resistance wire is doubled up by folding. Calculate the new resistance of the wire. So let us see this. So let us suppose we have got a wire like this in the cylindrical form. Is it okay? So its length is L, its area of cross section is A. So its resistance will be given by rho L over A, and its resistance they are saying is how much? It is 10 ohms. So we write 10 ohms here and call it the first equation. Now what they are saying? They are saying that we are doubling it up by folding. So let us say from this point we have folded it up and it appears somewhat like this. So you fold over here and you see you get it in this form. So you can treat it like this, you see. Is that okay? So what do you observe? Do you observe that there is some change in length? So from the center, if you have folded it up, obviously the value of new length will be what? It will be L by 2. Got it? And area of the cross section that you can see over here and here, it will not be A, it will be A dash, which will be nothing but twice of A. So let us see, and the material remains the same. We are not changing material. So what is the new value of resistance? R dash, let us call it. It is rho L dash over A dash. So what we can write here, rho, what is L dash equal to? It is L upon 2. And what is A dash equal to? It is twice of A. And you can write this up like this. So you can write it rho L over A. We have to get it in this form because in place of this you can replace what? 10 ohms. And what is extra over here? This 2 will go in the denominator, multiply with 2 and will give you 4 in the denominator. So let us call it the second equation. Now, first equation, when used in the second, we can easily see what is R dash equal to. It is 1 by 4 times of what? R. And what is R? Rho L over A, that is 10 ohms. So we can write it 2.5 ohms. So this is the way we get answer to this question, C part. So found it very simple. So very systematically you have to proceed mathematically and you find the things very interesting and very simple. So I hope you found it quite interesting. See you in the next video. Bye bye.